I'm Sumit, and I'm going to talk about Slider with John Marone. So what we plan to cover today is spend some time on the background around Slider, which is essentially shares a lot if you have attended any of the Yarn talks or any other Yarn application-related talks. And then we will talk about some new changes that we have done recently to simplify the packaging, and then obviously go through what was the motivation behind it, etc. And followed by another feature that we added recently, which is rolling upgrade of applications that are running on Yarn using Slider. And then John will cover security and Docker integration and few of the key enhancements that happened with Yarn, as well as how Slider takes advantage of those enhancements. So to go through the background, so the general idea is pretty simple, or which is around for a long time, which is anytime you run an application, doesn't matter how your application is hosted, you run through a bunch of aspects of maintaining the life cycle of the application, which is anywhere from where do I run my application, how do I manage configuration, how do I go through version upgrade, or even as simple things as how do you stop, how do you start, etc. So these are the problems that are common across applications. Doesn't matter whether they're running directly on a VM, whether they're running through Docker or running through Yarn using Slider. So these are the problems that Slider tries to address. So roughly, it translates to the fact that I have a bunch of machines, and those actually have disks and some compute power. So what's the best way for my code to run on those machines, which are fairly reliable, they can actually fail, and while being a good citizen of the overall ecosystem of where you're running probably a multitude of applications. So that's exactly where Slider comes in. So the goal of the Slider project is essentially to make it easy to run applications using the Yarn capability of resource management, etc. So before we jump into Slider, this is sort of a very brief overview of how things happen on Yarn. So if you look at Yarn, I mean, this is fairly well known. So obviously, you have your resource manager, you have your node manager, and the basic idea being through the resource manager, you actually get allocation of resources based on what your constraints are in terms of how much CPU you need, how much disk space, or how much I/O. So Yarn is improving with respect to what are the various resources you can take into account in terms of scheduling my job. So you talk to the resource manager, and what you get from Yarn is an allocation for something called an app master. And the app master is basically your code. It just so happens that most of the app master actually share a lot of common logic. So it almost, you can think of the app master as a library. In fact, the Slider app master is probably very similar to any other app master you might actually already know. And then the app master now takes over on behalf of that application. So every application instance actually has one instance of app master. So what the app master does is it talks to resource manager and then again asks for resources, because app master is the one that is responsible for getting resources from Yarn and then using that to bringing up containers. And so that's the background with respect to how a general purpose application may be running on Yarn. So what Slider did is essentially abstract out the notion of, okay, there is an app master and there is a general purpose manner in terms of how you can run and how you can manage the life cycle of the application or workload, and capture that into an infrastructure that can be used to run various different kind of applications. So if you look at it from Slider point of view, an application will look like a set of components, which is essentially an abstraction that, for example, if Hbase is my application, then the components are Hbase master and Hbase region server. So in reality, me managing the application is actually managing the life cycle of Hbase master, Hbase region server, etc. So that, when combined together, provides the application view for Slider. So the component is basically the core workload that Slider is actually managing with through interaction with Yarn. So now let's go into simplified packaging. So the motivation for simplified packaging was, so when we started the Slider project, the goal was to look at applications such as Hbase, Storm, Accumulo, and there are a few other, and then try to figure out what is the best way to host these applications bring it onto Yarn, so that you can run Hbase on Yarn, you can run Storm on Yarn, and preferably you can run both on the same cluster or the same data center without having to create two different clusters, one for Hbase and one for Storm. So obviously that means you have to be a good citizen of Yarn, and then you have to respect the resource constraints, etc. So that aside, what we came up with is an application packaging structure, which I will just show briefly. But as it happens that not all applications have to be as complex as Hbase or as complex as Storm. So you can actually have an application where it is just a daemon that you just want to run in your data center. So Memcached happens to be one example of very simple application where you just start a daemon and then you just use it for your purpose. And so in that case, the question that comes up is, okay, so if I have a very simple application, do I have to go through to create the full application package and actually use Slider to run? So the answer is, yeah, obviously you don't have to do that. And that's where the motivation came in. So essentially, I'm going to switch over to a demo right now, where I will go through a simple program that is essentially, think of it like you're starting a Java process, followed by an application that is a simple program, but it decides to advertise something about itself. So for example, you want to know which host and port it is running. And then I will add a few extra complexity to the application. So, so in this case, I have just, I have a cluster where it's actually a single one node VM cluster. And I will use that to run sort of 3 different versions of Memcached. So right now, nothing is running. So let me just look at the command that will be needed to run this application. So if you look at it, the command is very similar to the Slider create command. So the big difference is that rather than providing an application package, we are actually providing in a JSON file what exactly this application corresponds to. So let me show you the resources.json, which is incidentally very similar for all the versions, so we'll just get it out of the way. So essentially, my application will have an app master. Like I said, every application running on Yarn has to have an app master, and there is a daemon Memcached. So let's look into the meta info file. And if you look through this file, all it is saying is my application can be started using this command line. And this is what you will do if you're just running it by hand. You can just go and do PDSH. There are various ways to deal with it. But so if my command looks exactly like that, can I run this using Slider through Yarn? So that's really the goal. So that's basically what we have here. In this case, what happens is that this application dependencies, the jars, etc., what you have, they're all available on your machine. So when you go the world of application package, you can actually capture all that in your own package. But in this case, your machine is already ready. All you need to do is execute the command. So let me just do that. Okay, so this is the command that will go ahead and create the application. And let's see. Okay, and this is the Yarn Resource Manager UI. And as you can see, that application is submitted and it is going through the process of being created through Yarn. So end of the day, what is happening is you get your same application master that actually talking, and then it has all the information that was passed through the metainfo.json and resources.json, and it is using that to talk to the resource manager and then creating an application which is basically just executing that command. So this is just the application being run. And because this application doesn't really do much in this version, because I'm not asking it to export anything, so I will just do a grep of so that's basically it. So as you can see, the command that you provided in the meta-info is pretty much translated exactly the same way. And then all you have is your application up and running. So now let me make some slight modification to this application. So let's see. I'm going to stop it, and I'm going to create another, I'm basically going to run another version of the application where the change is that this particular version, it decides to export some detail about yourself, about the application. So for example, let's go here. Okay. Okay, so this is pretty much the start command. And the biggest difference in the start command is that I'm providing it a configuration. So the question is, why am I providing it a configuration? So let me start the application, and while it is starting up, let me go through what exactly this configuration contains. So in this particular version of my application start, what I'm trying to do is, okay, you start yourself, but please advertise the fact that you are running on this host and this port. So if you look at the app config.json, essentially it is a placeholder to tell Slider that this version of my application would actually require a dynamically allocated port, and whatever port gets allocated will actually be known to the Slider infrastructure so that it can advertise it through the registry that Yarn already provides. And if you look at the meta info, it's the only difference really is that instead of providing a hard-coded port or relying on the memcached daemon's default port, I'm actually providing a symbolic name of the dynamically allocated port as a parameter to memcached. So if I switch to my browser, that other application is now gone, a second application has come up, and what you see here is in the exports, there is a section that is actually that is something that I have specified through my metainfo.json, where it is advertising the fact that it is running on this host and this port. So the only difference between the first version and this one is that in this particular application instance, I'm actually advertising the host and port. Okay, so let me stop that. And as you can see, there are various other commands that Slider has. I think there are a few new commands in terms of how you can list the applications that are running, how you can actually list the packages that you have installed, etc. So there is a third version that I had, which is very similar to what I just showed you right now, which is, and I'm not going to start this in interest of time, but I will just go through what is the big difference as far as this particular version is concerned. Because as you can see, what I'm going through here is through a slightly progressive pattern, you start with an application that does something more and more complex. So in this case, the big difference is that everything is being similar except for this application comes with its own version of jar. So I'm not going to rely on the jar that is present on the host, and I'm instead going to package the jar myself. So let's just look into the command that will be different. So the only difference that you will see between the previous version and this one is that I'm actually pointing my application start to a locally available folder where all the jar files are. So actually this locally available folder is fairly, what do you call it, dumb. So essentially what happens here is the Slider infrastructure, prior to creating the application, will go to this folder and essentially transport all of this through Yarn to the respective host where the application is running. So that's sort of a very, very simple way for you to copy over whatever files, configuration, jar files, everything that you have, and then move it on to the respective containers that Yarn allocates for you when you actually execute the application. And what your application can do is refer to that folder through the symbolic names that we already have, and then actually just use it for in terms of how you want to run your application. So, and then the next version essentially is what you do is you create a full-fledged package. So the idea is that we started with a package, and then we kind of moved backward from there to simplify by providing whatever default values that Slider can actually guess from the way you are starting your application, and then just hide those details so that if you have a simple application, you don't have to create a full zip file. That's really was the motivation. Okay, so let me just go back to the slides.
Questions now, or?
Ian.
Either way, go ahead, please.
So one question, is this
Yeah, so there are two parts to the question. One is whether it's limited to Java. So the answer is no, because what is going on as far as slider goes is literally takes a string, just execute this. And then that could be a shell script, Java, it could be Python, doesn't really matter. So, and the second part is this advertisement capability, is it registered with some DNS? So what is happening is that as far as slider goes, it is integrating with the registry feature that is available in Yarn. So slider application simply is sending the information back to Yarn. And what we have done right now is the slider AIM as well as the slider client is querying the Yarn registry to extract the information. And I believe there is a discussion going on the front where the registry that Yarn will have some integration to DNS or some other automatic lookup mechanism. Okay, so yeah.
One question is that, so you're talking about the Hbase over slide, right? So what's the difference between I deploy Hbase over Ambari and then the Hbase over slide over Yarn?
Yeah,
That's the
okay.
first question. Second question is that, what's the difference between like the case?
Oh,
Go ahead to the microphone.
The second question is what's the difference in terms of the use case you just saw us. So the difference between the distributed shell. I use a distributed shell to run the package or the command.
Correct. Okay, so the first question was what's the difference between Hbase running on regular VMs versus Hbase running through slider on Yarn. So on the first occasion, for example, if you're using Ambari deploy Hbase, then Yarn is actually not aware of the fact that Hbase requires this much of resource or Hbase is consuming this much of resource, etc. So essentially, whatever resources in terms of disk, CPU, memory is consumed by Hbase is something that Yarn doesn't know. So if you imagine a node where you have a node manager running and an Hbase region server running, then you really have to manually configure the node manager to say that, oh, okay, you only have 2 gigs of memory, even if the machine has, let's say, 8, because alternatively, you have configured region server to use up, let's say, 6 gigs. But if you go through deploy through slider and through Yarn, then all of this interaction actually happens first class with Yarn. So before we start an instance of region server, we will actually ask Yarn saying that, do you have a machine where there are 6 gigs of RAM free where I can actually run the region server? So what is happening in this case is whatever workload you are running, they're all registering their usage and the requirement with Yarn so that you have a much better flexibility with respect to where the workloads will run. But functionally, they are very similar. There is nothing difference between Hbase.
But the problem is that Hbase usually is a long-running service, right? So that means that I need to stick to my local data in the data node, right?
Yes.
You cannot randomly give me a node to run my region server.
I agreed. So to that problem, there are a couple of capability that Yarn has. So one is labeling. And then slider itself maintains a history of where the prior instances has started, sort of a stickiness aspect to your application running. So if you have used your labels properly, then you can constrain Yarn with respect to which nodes or the containers can come up. So that's one way for you to make sure that there is a data node on the same host where the region server is coming. And in addition, slider maintains a historical data with respect to where the instances came up before. So if the instance go down for some reason, there is a limit up to which slider will retry to bring the container back up on the same host. So there are a couple of these additional capabilities in slider and Yarn to ensure that you have a level of stickiness while enjoying some flexibility with respect to where your instances would come up.
So for the Ambari, because from HDP, right, I can install Hbase together with because they are individual service, right?
Yeah.
Slider is one, Hbase is one. So I like to learn the use case. So in the case I need to pick up slider first, or I just install both, and later migrate my Hbase over slide over Yarn, or just keep the original.
Yeah. So
what's the use case?
Okay, I think what we'll do is we can talk more after the, but in any case, it's really how you want to run your Hbase. So you can, if you want to run Hbase where it is registered through yarn, if you want to run multiple instances of Hbase, then you can certainly start them through Slider. But you definitely have the option of running it directly from the directly on the machines. So, but we can definitely talk more. Okay, so I'll just quickly run through these slides, which are essentially what I just showed you in the demo. The only thing that I wanted to spend some time on is that if you look at this particular slide, this is roughly the outline of a simplest application package. And what we did was that we extracted out some of the details that are not necessarily required for your application. In that case, you just don't have to specify it. But the old style of creating an application package still remains. Okay, so the next topic I wanted to cover is application upgrade. And so before I go into application upgrade, roughly this is the very high level view of how Slider looks when you look at in conjunction with the yarn, resource manager and node managers, etc. So there is a Slider client, and there is a Slider app master, and there is a Slider agent that is actually running alongside your workload. So for example, if you have Hbase region server, Hbase master, there is a very small Slider agent, which is a Python code that is running alongside with that particular process. The purpose of the Slider agent is to monitor heartbeat, do port allocation, sometimes actually perform complex configuration operations if that is needed for your application. Because for example, for Hbase, you may have to create, site XML file, hsenv.sh, etc. Okay, so this kind of plays a role in terms of upgrade. So the motivation for rolling upgrade is as follows. So one, of course, it is rolling upgrade so that you don't lose your application while the upgrade is happening. So there are various upgrades you can think of when something is running through Slider. So one is you can upgrade yarn, but if you have yarn HA enabled and if you have yarn work preserving restart enabled, then the idea is you can upgrade your yarn and your application will actually not see any interrupt. So then you can upgrade Slider itself, which basically what we guarantee is as long as there is a backward compatibility between the new version of Slider and the old version of Slider, then it doesn't actually interrupt your application. But as of today, if you want to upgrade the Slider app master, which actually has a ton of binaries, then you need to stop your application, but that's something that we are working on. I'll just finish 2 more slides and then get to your question. So, so what Slider supports today is a rolling upgrade. So essentially what happens is that you have deployed one version of your application and the application is running. What you do is you deploy the next version of the application, and there are specific commands such as Slider upgrade that is in place to switch the definition from your old version to the new version. And then after that, you simply go through a restart of the containers to actually upgrade your application. So that's a very high level what is happening here. So I have a demo, but I think in the interest of time, I will not go into the demo right now. If we have time, I can definitely come back to this one. But this is the summary of what all you just have to do. So you create your application, and then you upgrade the application definition, and then you just simply go through restart of the various components. So if you're running Hbase, you restart your Hbase master, you restart your Hbase region servers, and when they come up, they basically come up with the new definition of the application. So that's really the rolling upgrade. And so I'm going to skip the demo for now, but if you look at the definition, the minimal upgrade you really need is to simply point your application from the location where the old version of bits are to the new version of bits. So that's really the crux of upgrade. So right now I'll have John come over and talk through the other features, and yeah, if I have some time, I can come back to upgrade demo. Yeah, thank you.
All right. Cool. All right. Oh, where's the clicker? That button?
Yeah, this one. Yeah.
No. I'm not doing the demo yet. I'm still on the slides. Sorry.
Yeah, wrong keyword.
Okay. Okay, so when talking about security, there are basically two major facets that we need to be concerned with. First, there's the security for the application master itself. So in a secure cluster, Slider itself has some responsibilities in terms of interacting appropriately with the security resources in the cluster. And then there are specific security concerns for the application itself. So take Hbase, for example. You're going to need to point to the appropriate key tabs for the region server and the master. You're going to have to specify the appropriate principals, et cetera, et cetera. So we have to manage, or at least provide facilities that allow for the application master to do the appropriate things in terms of security and support the application's security concerns as well. So to that end, the application master itself has some security configuration associated with it. It's in terms of like a service key tab, a principle that's used to authenticate essentially the application master's identity to the KDC. And then the applications themselves have the key tab, like for a given application configuration, there are key tabs that need to be specified, principles that need to be specified, and potentially even localized, because you're not sure exactly where these application components are going to come up. So we provide some facilities that allow for that to be supported as well. So just from a secure perspective, just an end-to-end sort of image of what happens, the client or the user is going to authenticate very much like anything, like in a cluster, is going to authenticate using something like KNIT to the KDC and invoke the Slider client, which will then launch the application master. The application master is configured with a key tab, so it starts up and authenticates to the KDC, and then the application components are going to start up. They're going to be passed configuration. That configuration is going to be populated appropriately with the locations for their key tabs, et cetera, and everything will start up appropriately. Just in terms of transport, we should mention that that the agent and the application master interact over SSL, so there is transport level security. It can be one way, it is one way by default. We do support two-way SSL as well. So that's sort of the basic security infrastructure that's been in place for a while. Some of the new features in terms of security are our ability to, you have two options, right? There is the manual distribution of key tabs, and then in your application configuration, you're referencing sort of those static locations, those static well-known locations for key tabs on the various nodes of the cluster. And that static location is configured within the application configuration that is defined in that app config that Sumit showed earlier. The other option, though, is for you to pre-populate the key tabs that you need into an HDFS location specified in the application configuration. And then we actually leverage Yarn's localization features to distribute the key tabs to the various elements of the application. From an SSL perspective, we've run into some applications, most notably Accumulo, that wanted to have the ability to actually distribute or manage the certificate stores as well. Again, you're not sure exactly which host you're going to come up on, so the ability to sort of create a key store specific to a given host and then distribute that key store and make it available to the application component was something very attractive for Accumulo. So we went ahead and implemented that feature. So you can actually, through configuration, specify that application components require a key store to be generated. So we'll generate the certificate, create the key store, and distribute it again using the localization features of Yarn. Okay, so that's the security enhancements. We've also done a Docker integration. Now, the Docker integration that we've done takes advantage of the packaging options or the new application launching capabilities that we've created that Sumit demonstrated just a few moments ago. So what essentially happens here is that the application master is launched with the appropriate configurations, meta infos, et cetera, the files that sort of specify the Docker images and potentially the configuration these images require. And the application manager launches the containers that have a slider agent running within them. Those slider agents actually at that point interact with the Docker daemon to launch Docker containers with the appropriate images, et cetera. So it's very similar to the exec scenario that we displayed earlier. It's just that in this case, the execution is an interaction with the Docker daemon to launch the Docker containers. So again, very similar to what Sumit demonstrated, what you need is an application definition, the meta-info JSON, in which you'll see that it defines things like the image required for that particular container launch. And then the application configuration will specify any configuration parameters that are required for that particular launch, for the image to be configured with during its launch. And similarly, resources.json is a file that describes the yarn requirements for those particular components, for those particular containers, the memory requirements, et cetera, the number of instances required, those sort of things. So let's take a look. If you look at the meta-info JSON for a typical sort of Docker launch, or the one we'll probably demonstrate here, is you'll see that there's two containers there are two components defined for this particular Docker application. There's a Node.js component and a Redis component. And you'll see that there things are specified that you'd expect for a Docker launch, such as the image, the name of the component, the port configuration for that particular Docker container, et cetera. So this is, again, meta-info.json is sort of where you define the scope or the components of the application. The resource.json, again, as I mentioned, is sort of the where you define what are the yarn resources I need for this particular application. So when you think of resources.json, think of it as basically the definition of the yarn in interaction. And as I mentioned, the app config is going to provide some sort of configuration that would be required by these particular components. In this case, for Node.js, you'll see that there's a property being passed in indicating on which host the Redis data store is running. So if you take a look at the commands that we'll run through for running a Docker application, they're again very similar to this process you saw earlier. You'll create an application instance. You can take a look and see if you can list the application once it's running, and then you can go through the life cycle of that application. You can start it, you can stop it, etc. So let's switch to the demo box, and I'll do a quick demo. Sure, go ahead. Actually, I'll just hit start and then go ahead.
Can you compare this to the CloudFront?
The CloudFront.
CloudBreak?
Can I compare the Docker demonstration to?
There's a way to launch things this way versus
The question was to compare this infrastructure to what CloudBreak does.
We can take it after. No.
What's that?
After the demo, we can.
Okay. Yeah. Why don't we'll take that on as the first question after the demo. Okay. So what I did here was basically I restarted. Actually, I skipped the creation step. I've already created an application instance. I just went ahead and started this application instance. And again, what's going to happen here is an application master gets launched, 2 containers gets launched. Each of those containers is interacting with the local Docker daemon to create a Docker container, have it start up and run. And hopefully, once we take a look on those particular hosts, after about a minute or so of us waiting breathlessly, you'll see that 2 Docker containers started up. I have this incredibly advanced UI, and you'll see that that incredibly advanced UI just took care of interacting with from the node container to the Redis container to insert one key value pair. So I'll work on the UI some later on. Can we switch back to the slides? All right. Okay, I'll quickly go through some key enhancements. On the Yarn side, there have been a bunch of enhancements, and you can, if you look at all these enhancements, you'll see that the common thread is that they all somehow, I mean, they're not necessarily intended primarily for long-lived applications, but the slider's primarily focused on long-lived applications, so a lot of these enhancements enhance or enable us to do better things, better management for long-lived applications, as opposed to the bread and butter for Yarn currently, which is these short-lived applications. So let's talk, just focus on a couple of those enhancements. Service registration and discovery. Again, you saw a demonstration of the usage of the registry earlier when you saw that these exported parameters are available to you from the Yarn registry. You can take a look at these exports. So from a client perspective, it's very important for when we're launching something on a Yarn cluster, especially if we're going to use it over a long period of time, to understand exactly where it's running. So Slider takes care of the registration of anything you need, published to the registry, published to it, as well as refreshed. Say when a container is restarted, if it starts up somewhere else, we take care of the refreshing of that data, the host and port, for example, in the registry. We make use of the registry also internally. So when a container starts up, it interacts with the registry to find out where the application master is running. Because again, the application master in some scenarios can actually be restarted. And in those cases, we leverage the registry to republish the application master's address. The Slider agents that are running within containers take care of sort of looking up the new location for the application master, and communication continues between the two. Another thing we took advantage of, and that Sumit mentioned earlier as well, is node labels in Yarn. What we basically provide through Slider is, through configuration, a mapping between components or roles and labels. So basically, you can designate that the region servers of my Hbase deployment are to be deployed to the following set of nodes, to this labeled set of nodes. Okay, a quick talk about placement. I guess I'll run through this quickly because we're running out of time, but basically the idea here is that the scheduling within Yarn is primarily focused on short-lived applications. And some of those considerations for placement in terms of short-lived aren't actually valid for long-lived applications. So for example, when we initially requested that a container, a specific node for a restart of a container because that container was running in it previously, the wait time that Yarn provided was on the order of seconds. So if that container didn't become available in a few seconds, it moved on and placed it somewhere else. So what we've done in Slider is take some responsibility for that scheduling by sort of extending that period of time. So by default, for long-lived applications, now we can wait for a given container to become available on the order of minutes as opposed to seconds. We even have the policy. We've run into certain applications where their requirement was wait forever if you have to for this particular container because it's just too expensive to restart on a different node. So that you can actually specify a strict placement policy, in which case we'll just wait forever for that given node if need be. So in conjunction with placement, or in conjunction with this idea of escalating or extending the period of time, we've enhanced our role in node failure so that we make more intelligent placement decisions. I can talk more about that if somebody wants to come up afterwards, but for now, let's just get to the end. Okay, and that's basically it. Okay, now your initial question was the difference between Cloudbreak, right? Do you want to take that, or you want me?
I'll take that.
You want to take it?
I'll just connect this one as well. 30 seconds. Yeah, so what Cloudbreak has a couple of capabilities. So for example, if you are actually interfacing with any service providers such as EC2 or Azure or GCE for that matter, then Cloudbreak sits in between you and your communication with the service provider and then provides you a way to build the Hadoop cluster using Ambari. So what it actually does is it deploys an Ambari, and then it can deploy Docker containers that already has images pre-installed for various Hadoop pieces. So starting anywhere from Zookeeper all the way to Hbase, Hadoop, etc. So in that world, you are getting a full Hadoop cluster. So for Slider, what it is actually doing is that it's essentially starting a Docker container, whatever your Docker container may be. It doesn't have to be anything related to Hadoop. It can be just a standard Docker container. So that's really the difference.
Or in a more general sense, it's just you're starting up a cluster within Yarn. So Slider is facilitating your usage of a subset of that Hadoop cluster that got posted to deploy your particular application within those resources.
Can we switch it to the demo laptop?
So I suppose conceivably you could use both. You could use Cloud Break to set up the cluster and then
Yes.
use this to deploy onto it. That seems redundant. Wouldn't there be, like, would you actually go with Cloud Break deploying something with arbitrary Docker container?
Oh, so your idea is you could define beyond just the Hadoop cluster, define the elements that get deployed within the cluster through Slider.
So, well,
Well,
I guess that's an integration possibility somewhere down the line.
okay, go ahead.
One more question?
So I have more fundamental question. So is Slider runs on top of Yarn? And next question is, what is the order of starting of the services? First you start the node managers, then the Slider,
Yeah.
or how does that work? And also Slider's HA capabilities. If Slider application manager dies, what happens?
Yeah, okay. So Slider doesn't have a runtime. So Slider is essentially a tool that interacts with the Yarn. So in effect, you need to have your Yarn cluster up and running. So you start your resource manager, node manager, whatever else you need, and you have that up and running. So Slider provides a bunch of client capabilities that brings up the Slider AM, then followed by whatever container needed to manage your workload. Now the way high availability for AM works is that if AM goes down, then Yarn will make sure that a replacement AM comes back up, subject to, of course, resource availability, etc. And what the capability that Slider has is, if an AM goes through a restart, then the agents that we talked about earlier, they have the ability to discover the agent through the registry, like John mentioned, and then re-register themselves back with the AM. So yeah, if I could show the upgrade demo, it actually takes advantage of that particular feature as well. So that means the AM within few minutes or so will actually know, again, what the current status of the cluster is, how many containers are up, if anything went down. So sort of business runs as usual after AM comes back up. So HA basically relies on the fact that Yarn is going to bring it up if it goes down.
So in your Hbase example, right? So we were using Slider to make Hbase play nice, and for example, that region server, you will only use sys give or run, something like that. But is this being enforced by either Slider or Yarn? Like, is a real constraint?
Yes, so Yarn can be configured to enforce the resource constraint that you have defined. So namely, if you exceed the whatever is allocated, it will basically just kill the container.
Right.
So it is, yes.
For any kind of resource or just memory?
Sorry?
For any kind of resource or just memory?
Oh, so right now I believe it is memory and CPU.
Memory and CPU.
then I think there is work going on related to I/O and maybe networking.
Yeah.
So Yarn orthogonally is adding more and more capabilities with what it can actually monitor and what it can enforce. From Slider side, we just simply make use of that.
All right. Sorry, I'm blanking out. Go ahead.
Okay.
So what about the Nagios integration and all the kind of logging and that kind of stuff that you get through Ambari?
Yeah, so for example, right now, the Slider application package structure can integrate with Ganglia as well as the Ambari metric server, both. So what really happens is that the packaging logic or the logic of what you do when you configure your application, essentially make sure that your metrics2 file for Ganglia or for AMS is laid out properly so that the metrics can go to respective. As far as alerts goes, I mean, there is nothing stopping it from the slider applications to create alerts. It's just that we haven't yet created example integration to Nagios.
So the nice Ambari dashboards for Hbase, you won't get those when you're running it through Slider?
At this point, no. But that's one of our work items from the slider side to figure out a way to. So Ambari, so what we did, I think about 7-8 months back, is created a view in Ambari where you can see your application, you can control the life cycle of your application. It's a very, very bare minimum, but yeah, you don't get all those niceties rest of the Ambari provides.
Okay, thanks.
My next question is, using Slider, let's say you have two applications. So using Slider, you start application 1 and application 2. Then does it start two different application managers?
Yes, two different application masters. Actually, we'll just get down the podium in case you have more questions. Thank you.
Thanks.